Welcome friends. We have been discussing sets, and we have now had a look at what are the elements of a set, how do we represent the set in two different forms, then the types of sets including the finite and infinite sets, empty or null or void set, and equal set. Then we also talked about the sets, subsets and supersets. We also talked about the formula which can be used to calculate the number of subsets that a set can have. We also talked about the power set, the universal set, the complement of a set which is denoted by A dash, and we had attempted some questions as well. And we had also talked about the Venn diagram which can be used to represent the sets, and we discussed how Venn diagram is used to represent the universal set and its complement. Now we are going to discuss the operations of sets. How are operations of sets conducted? So what do we mean by operations? Operations basically mean how do we multiply various sets, or how do we subtract one set from the other. These kind of operations, there are some particular rules that we have to look at. So this is going to be the agenda in this particular session. So let us talk about the operations of sets both mathematically and using the Venn diagram diagrammatically. So we'll be taking care of both the mathematical operations and how do we represent the same operations diagrammatically using the Venn diagram. So the first thing that we'll have to look at is the Cartesian products of sets. What is the Cartesian products of set? So it is basically the product of two non-empty sets. So Cartesian product is the product of two non-empty sets. How? Let's take an example. For example, A has two elements 1 and 5, set B has three elements 2, 4 and 5. Now the Cartesian product would be A into B. And how do we find out the value of A into B? Every single element of the first set will be multiplied with every single element of the second set unless and until we exhaust all the elements. So the first element of set A was 1, so we are going to multiply 1 by all the elements in set B. So we get 1 2, 1 4 and 1 5. Then for the second element of A, which is 5, again we will conduct the same operation. We will multiply it with all the elements in set B. So we get 5 2, 5 4 and 5 5. So this is the Cartesian product of the two sets A and B, and we denote it by A into B. Now what would be the number of elements in the Cartesian product? It would basically be the product of elements in the two sets that you are multiplying. For example, here the first set A had two elements, so the product will have 2 into 3 is equal to 6 elements, and now you see that A into B has got 6 elements separated by comma. So the first element is 1 2, the second one is 1 4, then 1 5 and so on. So this is how you find out the Cartesian product of sets. We can also find out B into A. Again we'll use the same procedure, but since we are stating it as B into A, we'll start with B. Every single element of B will have to be multiplied by every single element of A. So now we get this result. B into A is equal to 2 1 and 2 5, then 4 1 and 4 5, and then 5 1 and 5 5. Now if you look at the two expressions A into B and B into A, you would find out that they are basically equal. because we have seen earlier also that the sequence is not at all significant, so you don't need to worry about the sequence. So 1 2 in A into B, the first element 1 2 is equivalent to 2 1 in the B into A product. Likewise 1 4 in the first product A into B is equivalent to 4 1 in the second product B into A. So likewise, if you do the calculation, you will find out that both the sets are equal, and this gives us a general rule that the Cartesian product of two sets is equal no matter which set comes first or which set comes second. The product would always be the same, that is A into B will always be equal to B into A. Now let us talk about the union of sets. What do we mean by the union of sets? Union of sets would include all the elements present in each of the sets. So if we are going for the union and we are taking two sets, all the elements present in both the sets would be included in the union. So let's take an example. For example, if we have got two sets, one is A which has three elements 1, 3 and 5, the other one is B which has 4 elements 2, 4, 5 and 6. Now if I want to find out the value of A union B, it should include all the elements present in each of the sets. So in A there were 1, 3 and 5, while in B there were 2, 4, 5, 6. So now A union B should have all the elements present in both A and B, and you look at the value here 1, 2, 3, 4, 5, 6. This includes all the element of A, i.e. 1, 3, 5, and it also includes all the elements of B, that is 2, 4, 5 and 6. Now this is the value of A union B. You need to understand the fact that in case one particular element is present in both the sets, we don't need to mention it again. So you can see here that 5, which was common to both the sets A and B, it was also mentioned just once. You don't need to mention it twice. Now let us take an example. Example number 2. A has got 4 elements 2, 4, 6, 8 and B has got 6, 8, 10 and 12. You have to find out A union B. So A union B should have all the elements of both A and B, and that is why A union B is equal to 2, 4, 6, 8, 10 and 12. Again, as I said earlier also, the common elements will have to be taken only once. So you don't need to include them twice. You will only have to include them once. Example number 13. A is a set of all the vowels and B is a set which has 3 elements A, I and U, and now you can show that A union B is equal to A. So A union B should have both the elements of A and B. So A union B becomes A, E, I, O, U. Now all these elements, since they are present in A also and all present in B, they are forming the set A union B. Now this example also tells you that if there is a set and if there is a subset, then the union of the set and the subset will be equal to the set. Here you can see that B basically is a subset of A. B has all the elements. B has 3 elements and all these 3 elements are present in A. So basically B is a subset of A. So A is the set while B is the subset. So when you find out the union of a set and its subset, the union will have all the elements present in the set, and that is why A union B is also equal to A, E, I, O, U and equal to A. So whenever, the general principle is, whenever you find out the union of a set and its subset, the union will be equal to the set, which has happened here also. A union B is equal to the set A, because B was the subset of A and we wanted to find out the union of A and B, or in other words the set and its subset. So A union B will be equal to A. Now you have to remember this general principle. Now let's find out how we represent union of sets using the Venn diagrams. We had seen yesterday what Venn diagrams are, and we had also learnt that basically the Venn diagrams were for the first time given by Venn, who was a mathematician, and that is why they are named after him and they are called Venn diagrams. Now see, this is A. We have taken all the values from the previous slide. So this is A, and we are showing it with a circle, and this is a grayish kind of a circle. We are not only showing the set A, but we are also showing its elements. The elements have been shown as 1, 3 and 5. And suppose I want to find out its union with B. B is another set which has got 4 elements, 2, 4, 5 and 6. So now if you want to find out the union, what are we going to do? See, this is going to be represented like this. Now if you look at the third figure, or the rightmost figure, you see that there are two circles which are overlapping. Basically they are A and B, the two sets overlapping, and the overlap basically means the common part. Overlap is that element which is common to both A and B. Now look at A and B. On the left of the screen you would find that one element 5 is common to both A and B. So on the right side of the screen you see the overlap, and the one element which is there in the overlap is 5. But you should also understand that this grayish circle and the bluish circle, when they are both overlapping, even then if you look at the outline of the grayish circle, you would find that it has all the 3 elements, 1, 3 and 5. While if you look at the outline of the bluish circle, you would find that it has got 4 elements, 2, 4, 6 and 5, with the element 5 being common to both A and B. Now this basically is A union B. So this is how you represent A union B. So the two circles, when combined, they form A union B, and if at all there is an overlap, if there is a common element in both the sets, then the two circles will also overlap, just like it's been shown here. The common element was 5. Okay, and A union B is the figure in the totality, which means the overlapping area plus the two circles. This is basically A union B, and we have shown the extent of A union B using this yellowish double-headed arrow. Now let us talk about intersection. What do we mean by intersection? So what is intersection? Intersection basically is the overlap. Just now we were talking about the overlap. You remember here 5 was the element which was common in both the sets. Now this portion wherein the first circle and the second circle are overlapping. Look at the figure at the right side of the screen. So the two circles are overlapping, and the overlapping, the portion which is getting overlapped, basically it has one element which is 5. Is this okay? Now this particular portion where the bluish and the greyish circle are overlapping and has the element 5 is called the intersection. Intersection includes only those elements which are common in each of the sets. So if you are trying to find out the intersection of two sets, if there is one element which is common, or maybe more than one elements which are common to both the sets, they will be basically representing the intersection of the two sets. Let's take an example. For example, A has got three elements. Again, we are continuing with the same example. We are using the same values to discuss the various concepts. Now A is equal to 1, 3, 5. It has got three elements, while B is equal to 2, 4, 5, 6. It has got four elements. What is A intersection B? A intersection B. Now what is the symbol of A intersection B? Intersection symbol is inverted U, as you can see here in line 4, A intersection B, and the A intersection B is nothing but the element which is common to both A and B, which is 5, and that is why A intersection B has been shown as 5. Now, did you notice a mistake on the slide? Yes, there's a mistake on the slide, but you do make the amendments in your notebook. The intersection of sets, intersection is shown by inverted U, not U, and U in fact is used to denote union. So there's a mistake in this slide, so please do make corrections. Intersection is denoted by inverted U, just like it has been shown in the fourth line, A intersection B is equal to 5, while union is denoted by U. Now again, let us have a look at the representation through the Venn diagrams. A intersection B has to be found out. Now, there are two sets A and B. The first set has three elements 1, 3, 5. The other one has four elements 2, 4, 5 and 6. And now, when they come together to form A union B, there is a particular portion of set A which is overlapping set B. So there's a particular portion which is common to both set A and B, and that particular portion contains 5. Look at the picture on the rightmost side of the screen. So if you look at the first circle, that is basically denoting set A. The second circle, which is overlapping the first circle, is denoting set B, which has 4 elements, and the only element which is common to both is 5, and that is why we show this particular overlap. So the overlap is showing 5, and this, now look at the arrow, this is the portion which is going to be called A intersection B, or the portion which is common to both A and B. It is part of both A as well as B, and that is why it is common to both of them, and that is why we denote it by A intersection B. This is okay. Now let us move ahead and let us talk about the difference of sets. A minus B. Now what do we mean by this here as far as sets are concerned? See, A minus B will be a set which will include all the elements which belong to A but are not part of B. So all the elements which belong to A but they are not there in B, they will form A minus B. We will take an example to make you understand this better. For example, A is a set with 3 elements. Again, we are taking the same values, just the way we did it a little while ago also. So the same values are being taken here. A is equal to 1, 3, 5. It has got 3 elements. B has got 4 elements. And now if I want to find out A minus B, so I'll have to do what? Let's look at the first line which is there. All the elements belonging to A, but they should not be belonging to B. Now A has got 3 elements, 1, 3 and 5. Out of them, 5 also belongs to B. So A minus B, we have said it should contain all the elements minus the elements which are there in B. So ideally it should contain 1, 3, 5 minus the element which is also there in B, that is 1, 3, 5 minus 5, and that is why A minus B should be equal to 1 and 3. 1 and 3 are the 2 elements which belong to A, but they are not to be found in, but they belong to A and 5 is the element which also belongs to B, so I have basically eliminated 5, and that is how we have got A minus B is equal to 1 and 3. So please understand this mechanism better, because we'll be using this for solving various practical questions later on. A minus B is equal to elements belonging to A. So elements belonging to A were 1, 3 and 5, but since 5 was also part of B and we should not have included B or any element which is part of B, that is why we eliminated 5 and we got this result: A minus B is equal to 1 and 3. Now let us find out the value of B minus A. Now what will be B minus A? B minus A should have those elements of B which don't belong to A, which are not also found in A. Now you have a look at B. B has got 2, 4, 5 and 6. Out of these 4 elements, 5 is also there available in A. So B minus A, when we are calculating, we'll have to leave out 5. So 2, 4, 5, 6, this is what the value of B is, but we'll have to leave out 5 because it is also part of set A. So B minus A will be equal to 2, 4 and 6. Now this will also give you a general rule that says that A minus B is not equal to B minus A. You would remember that as far as the Cartesian product was concerned, A into B was equal to B into A, but this is not the case here. A minus B is not equal to B minus A. So please do retain this information. Now let's talk about the diagrammatic presentation of difference of sets. A minus B we have discussed just a little while ago. So how do we represent it using diagrams? This is A minus B. So we have seen mathematically A minus B should have only those elements of A which are also not part of B. So 1, 3, 5, out of that 5 was the part of B, so basically A minus B came out to be 1, 3. This we have just now seen. Now how do we represent it diagrammatically? So A minus B we have written. Okay, and we are showing, have a look at the picture at the right extreme. Now we are showing the element 1, 3, we have got 1, 3, 5 are the elements basically in A, out of which 5 is overlapping with 5 of set B. Likewise set B has got 2, 4, 6 and 5. Now you know that this is basically A union B. This is just to make you understand, this is basically A union B. Now this portion, grayish portion, basically has only 2 elements, 1 and 3, and these are the elements which were there in A. But they were not there in B, and that is why the value of A minus B was basically 1, 3. So this portion is what A minus B is. So what you have done, from the circle or the oval which is representing A, you have to eliminate those elements which are also found in B. In this particular example, the only such element was 5. So we'll eliminate 5 and we'll be left with 1 and 3, and that is what A minus B is all about. Now can you find out A intersection B? You understand that this is the intersection part, that element which is common to both the sets, and now we have got this formula. See what the formula is. A union B is equal to A plus B minus A intersection B. Now what do we mean by this? Have a look. Okay, A union B, this is pretty clear. This is to the left side, the diagram is to the left side. You see the first oval which represents A with 3 elements. You see the second oval which represents B with 4 elements, and when you are trying to find out the union, this is what you will be getting. Out of this, 5 is the common element which is common in both the sets, and that is why we are denoting it as A intersection B. But then, do you understand how we got this formula? Okay, so let us try and understand how do we get this formula. Okay, A union B to the left side of the screen, and then let's move to the right side. The two circles are overlapping, and you see A intersection B being shown with an arrow. The element is 5, and there is just one element in A intersection B. Now what has happened, basically, if you want to find out A union B, what you'll have to do is basically the two circles will have to be added up, but then the overlapping area gets counted twice. When you add up the two circles, the overlapping area, which is A intersection B, gets counted twice, and that is why you have to remove it once, because it is getting counted twice. So what you do basically is you remove it once, and that is why A union B becomes A plus B minus A intersection B, because actually what was happening when we were trying to find out A union B, the area which was overlapping, that was getting counted twice. That was basically included twice. So since it has been included twice, though in the figure it appears only once, though in A union B, the figure which represents A union B, it appears only once, so you have to subtract A intersection B from A plus B to get this particular formula. So this is the formula that you will have to keep in your mind. This is the relationship between the union and the intersection. A union B is equal to A plus B minus A intersection B. Why I am trying to prove this formula using this diagram also, using Venn diagrams also, so that you can understand the meaning of the formula and can make sense out of the diagram or the Venn diagram which is given to you. So A union B is equal to A plus B minus A intersection B, and we were subtracting A intersection B because actually it was getting accounted for twice when we added up A plus B. So we had to reduce one extra intersection B that was getting counted twice, and that is why we have A union B is equal to A plus B minus A intersection B. Well, we are continuing with the same example, no change in the values. You understand that this is basically A intersection B. Now what is this? This is those elements, this basically portion, the portion which is shown in gray and does not include, please mind it, it does not include the overlap. So we are as of now referring only to the portion which is shown here by the gray color. We are not actually taking account of the overlapping area. So we are referring to just the grayish part. Now what is basically this? You would recall from our earlier discussions that this is nothing but basically A135 minus the overlapping part, that is 5. So basically 13 is nothing but A minus A intersection B, the whole of the circle which is representing set A minus the intersection part. This gives me only A, or A minus A intersection B. Likewise, this portion is B. B had 2, 4, 6 and 5, but out of that I am only taking into account 2, 4, 6 and I am eliminating 5. So basically this is nothing but B minus A intersection B, or we can many times this particular way of denoting this portion in the Venn diagram is used. We call it only B. Only B means those elements which are present in B and not present anywhere else. So this is what is the meaning of only B. And here only B is equal to 2, 4, 6. B is equal to 5, 2, 4, 6. Now please understand the difference. A is equal to 1, 3, 5, and we had seen that in the left portion of the screen also you can see A is equal to 1, 3, 5. But what is only A? Only A is equal to only 1 and 3 and not 5. And this is being shown by the formula. Only A is A total minus A intersection B, which means 1, 3, 5 and minus 5. So only is basically that portion of A which does not overlap with the other set B. So 1 and 3 is equal to only A. Likewise, we have got only B, which is equal to 2, 4, 6. And I am saying this again, don't confuse only A with A. A means 1, 3 and 5, while only A means only 1 and 3. And how do you get only A from A? You have to reduce, you have to actually get rid of the overlapping part, and that is what you have done in the formula. A minus A intersection B is equal to only A. Now this is the formula that we'll get. A union B is equal to, now let's have a look at the formula again. A union B means the two circles coming together, and these two circles, when they come together, they form a figure which looks like the figure on the right side of your screen. And this figure is basically made up of three components. The first component basically is A minus A intersection B, or only A. The second component is the intersection A intersection B, and the third portion is basically B minus A intersection B, or only B. And when we add them up, A minus A intersection B plus A intersection B and plus B minus A intersection B, then basically we get A union B, and that is what has been shown in the first line here. A union B is equal to nothing but the first portion plus the second portion plus the third portion. The first portion is A minus A intersection B, second is A intersection B, and third one is B minus A intersection B. So we are adding them all to get A union B. Now when you further simplify this, minus A intersection B and plus A intersection B, the second and the third term in the first line after equal. The second term after equal is A intersection B minus A intersection B, The third term is A intersection B. So they will cancel out, and what are we going to be left with? A union B is equal to A plus B minus A intersection B, and this proves our formula. So friends, that's all for the day. I'm expecting that you would go through these video sessions thoroughly, because you may come across questions not only in the end semester exams but in the various competitive exams that you appear in, and that is why it is very, very important for you to be considerably proficient in sets. So kindly go through the video again and again till the point of time you understand every single thing that we have discussed. You may always pause the video, you can discuss with your batchmates, you can also refer to your books, and if nothing works out, you can always give me a call, and you can pose your query to me, and I'll be more than happy to respond to your query. Now in the next video session, what we are going to do is we are going to look at the practical implications. How do we actually practically apply this particular formula while solving the real world problems, and that is what is going to be the most important skill for you. So that would be the portion that we'll be covering in the next session. Till then, kindly keep going through this video and keep your notes also ready, so that when you appear in your test, which is going to take place very soon, you can refer to them. Thank you very much. and hope you enjoyed the